Hi everyone, and welcome to the channel. This video is going to be a deep dive into the wide variety of EC2 instances that are available today. Now I'm going to walk through each of the core EC2 instance families and also all the different technologies behind each of these instance type families. The lesson is packed with all kinds of visuals and study aids to help you remember all the information come exam time and really ensure you have the real world context to all the specific use cases all these different instance types are built for. When it comes time to having to pick an EC2 instance type and size, you'll be really well informed to make the optimal choice for your needs. So if you're studying for the Cloud Practitioner or any of the AWS associate level exams, this is going to be your ultimate guide to EC2 instance types. Now, if you like this lesson and you're beginning your AWS certification journey, my Solutions Architect Associate course is available now in its preview phase with about 15 hours of lessons recorded at this point. So if you want early access at a big discount, I'll include a link in the description below. Now, I figured I'd share this lesson here on the channel to help get some feedback and make future lessons even better. So please let me know in the comments what you liked. And if you have any suggestions on how to improve things, please let me know. But there's a lot to cover in this deep dive into EC2 instance types, so let's dive in. Hello, and welcome to this lesson on EC2 instance types. Now, understanding the different EC2 instance types available and the use cases for when and how to use the right one for a given purpose is really important for the exam and for the real world. Now, we have a lot of info to cover here on these EC2 instance types, so let's dive in. Now, Amazon EC2 provides a wide variety of instance types, which are essentially these pre-configured virtual servers with specific combinations of CPU, memory, storage, and networking resources. And all this choice gives you the flexibility to choose a server configuration that best matches your application's needs. Instance types can range from really small instances with modest resources to extremely powerful instances with dozens of vCPUs and hundreds of gigabytes of memory. Each instance type offers a slightly different balance of resources and performance characteristics, so selecting the right type is important for both optimizing cost, ensuring your applications and workloads run efficiently. Now, to make it easier to choose, AWS groups instance types into families based on common use cases and resource profiles. For example, there's instance families for general purpose use, for compute-intensive tasks, and even memory-intensive tasks, and so on. Each of these families is tuned to excel at a certain workload type. This means if you have a memory-heavy workload like an in-memory database, you might use a memory-optimized family, whereas if you had a CPU-bound batch job, this might run on a compute-optimized family. By offering multiple families, AWS lets you pick an instance that closely matches your workload's profile, avoiding overpaying for unnecessary resources or running out of resources that your app needs most. Now, as a best practice, you should choose the instance type by aligning it with your workload's requirements. You can start by identifying your application's bottleneck. Is it CPU or memory, storage or I/O, network, or maybe even requiring special hardware like a GPU? If you choose an instance type that provides the right mix of those resources, your application will perform well and you won't be paying for capacity that you don't use. For example, if your web server is mostly idle but occasionally gets bursts of traffic, a burstable instance might be a very cost-effective choice. If you're running a database that needs to keep large portions of data in RAM, a memory-optimized instance would be ideal in that type of case. Again, the main goal here is to match the instance's strengths to your specific workload use case. And this is a key skill for Solutions Architect and really helps ensure both performance and cost efficiency. Now, EC2 instance type names follow a pattern. The first part of an instance type name is a letter or letters that indicate the family or category. For example, the M stands for the general purpose family, C for compute optimized, R for memory optimized, T for burstable, P for GPU accelerated, and so on. This family letter immediately tells you the primary strength of that instance. So if you see an instance type starting with C, you know it's designed for compute. And then if it starts with an R, it's built for high memory needs, and so forth. AWS has quite a few families, including some specialized ones. But again, the idea is that the family name groups the instances by the type of workload that they're best suited for. Now, there's quite a few of these different instance type families and letters to remember, but don't go too crazy through this lesson here and taking notes quite yet, as we'll talk about the families more shortly and I'll also give you some ways to help memorize the different families and each of the primary purposes. Now, following the family letter, each instance type has a number that denotes the generation of that specific family hardware. Newer generation numbers mean a more recent version of that instance family, typically with improved processors, memory, and other enhancements. For example, M8 is a newer generation than M7, and AWS iterates on instance families over time. When new CPU architectures or faster memory technologies become available, they release a new generation, and the generation number increments in the instance type name. Now, a higher or newer generation usually means better performance or lower cost for that same level of resources because of those hardware improvements. Again, as a rule of thumb, you'll often want to choose the latest generation available since it offers the best price-to-performance ratio thanks to all those upgrades. So after the family and generation, instance type names often include one or more suffix letters that indicate the processor type or special features of that instance. The letters G, A, and I are really common as they denote the CPU architecture. G for the AWS Graviton ARM-based processors, A for AMD EPYC processors, and I for Intel Xeon processors. These suffixes tell you what kind of chip is powering the instance, which can be important for compatibility or performance differences. And there can be other suffixes added here as well. For example, D in an instance name means it has local disk, known as instance stored volumes. N indicates enhanced networking with higher network bandwidth. And E can mean extra capacity of some sort, such as extra storage or memory. Again, the main idea with these suffix letters is just, again, to communicate the special capabilities or CPU type. For example, an M8i is an 8th generation general purpose instance with an Intel CPU, while an M8G would be the same generation but with a Graviton-based CPU. Now, the instance type name ends with a size designation after a period, such as .small, .large, .2x large, up to .48x large, and so forth. And these instance sizes tell you how big the instance is in terms of vCPUs, memory, and other resources. Within each family and generation, you can choose different sizes. A larger size means more vCPUs and more RAM. As an example, X large might have 4 vCPUs and a certain amount of memory, while 2X large essentially doubles that. 4X large doubles on that again, and so on. AWS uses these sizes to offer linear scaling from very small to huge resource configurations within the same instance type family. The size naming of these instance types are essentially like t-shirt sizes for instances. This lets you right-size your instance for your needs. You might start off with a large and then down the road find out you need more horsepower to that instance. So you move up to an extra large or maybe 2 extra large in the same family. Now there's also kind of a special instance type size called .metal, which means you're essentially using the whole physical machine. These are a type of Amazon EC2 instance that provides direct access to the physical hardware resources of the underlying server without really any virtualization layer. These metal instances allow applications to run directly on the hardware, giving AWS customers complete control over that server's resources. Now, for some highly regulated industries with a lot of compliance requirements, these types of .metal instance types may be required, as they would arguably have a higher level of security since they don't have other customer instances running on the same physical hypervisor host. With these .metal instance types, you're basically renting the entire server hardware for only your use, and you'd have that true physical separation of your EC2 instance VMs from other AWS customers. So to quickly recap the naming convention again of these instance types, you start off with your instance family letter or letters, the generation, then the suffix indicating the processor or other special features, and then the size. Now, altogether, this defines exactly what resources and features your EC2 instance has to work with. Now, the general purpose family, indicated by M, offers a balance of compute, memory, and network resources. These instances don't necessarily specialize in one area, but instead provide a good mix that fits a wide variety of common workloads. If you're not sure which instance family to use, the M family is often a safe starting point because it's going to handle web servers, application servers, small to medium databases, development environments, and many other typical applications really well. Essentially, these M instances are the jack of all trades. They give you really solid performance across the board. They're ideal for applications that use CPU, memory, and networking roughly in equal proportions. For example, a typical web application or API server often fits this pattern, as do many enterprise applications. The M family's balanced nature means you're not heavily over-provisioning one resource to get enough of another. You essentially get a little bit of everything, and this makes them a popular default choice for general workloads. Now, the T family is a special instance type offering burstable performance. These instances are designed for workloads that don't need full CPU power all the time. They provide a baseline level of CPU performance and then allow you to burst above that baseline when you have temporary spikes in demand. Now, the way this works is that when the instance is idle or underutilized, it essentially accumulates CPU credits. And then when it needs to burst, it uses those credits to get more CPU cycles. This type of model is extremely cost-effective for workloads with low to moderate average CPU usage. Again, as an example, things like development or test servers, small databases, your blogs or websites with intermittent traffic, and some microservices often fit this type of pattern where they're mostly idle all the time, but occasionally they're busy with small peaks of load. These T-type instances are very cost-efficient. The T-family instances offer some of the lowest hourly costs in EC2, and you still have some capacity to handle short bursts when needed. They essentially help you avoid paying for large instance sizes that would otherwise sit mostly idle. Now, for these types of instance types, it's really critical that you monitor your CPU credits. If your T instances run really hot for kind of a longer period, you can burn through your CPU credits and run into some performance issues, but when used for their intended use case, they can save a lot of costs. So again, the T-family instances are really great when you want to optimize for costs and your usage is kind of spiky or periodic. You get that reliable baseline of performance to work with, and then the flexibility still to handle those peaks without breaking the bank. Now, still in this general purpose family, the newest generation at the time of recording here is the MAG, which is powered by AWS's latest Graviton 4 processors. AWS states that MAG instances deliver the best price to performance in the EC2 general purpose workloads. This means if your workloads can run on these ARM-based Graviton CPUs, you get more compute power per dollar compared to the older instances or older processor variants. Now, we'll discuss Graviton processors and instance generations in more detail shortly, but it's worth remembering that these G instances, like M8G for general purpose and the C8G for compute optimized and so forth, are often the price to performance ratio leaders in their category. The compute optimized instances, denoted by the letter C, are designed to deliver the highest possible CPU performance per instance, often with a higher vCPU count relative to memory. So in other words, the C family instances have a lot of processing power for the amount of RAM that they include. And these are ideal for compute-bound applications where CPU speed or the number of CPU cores is the limiting factor. These instances use powerful processors and typically run at higher base clock speeds. So if your workload involves heavy computations, this C instance family is where you should start looking. The memory to CPU ratio here is lower than the general purpose or memory families, which is fine if your app isn't necessarily memory intensive. This optimization lets you pay mostly for that CPU horsepower that you need without all the extra memory that you don't. Again, these C family instances are all about raw compute power. They really excel when you need to crunch numbers fast or handle a large number of compute threads in parallel. Compute optimized instances also shine in use cases where CPU is doing the bulk of the work. Examples here could include batch processing jobs like processing large data sets or media transcoding. They're also great for high-performance computing or HPC tasks like scientific simulations or genomic processing, video encoding, ad serving engines, even types of gaming servers with lots of kind of those physics or logic calculations. They can also be a good fit for certain machine learning inference use cases. Inference is just essentially the stage after you've trained a ML model and you're running the ML model itself. And this type of ML inference workload, especially if it's CPU-based inference, can be very compute intensive. So these C instances can handle that quite efficiently. Essentially, any scenario where you find standard instances hitting CPU limits, you'd want to start considering moving to the C family instances. These instances are built to provide consistent high CPU throughput. Many of the C family instances also support features like enhanced networking to ensure the CPU isn't starved for data. So when you think of lots of compute and not so much memory needed, again, think the C family. Now, the newest compute-optimized offering when recording here is the C8G family, which uses the AWS Graviton 4 processors. So just like with the M8G, AWS is advertising the C8G as providing the best price to performance for compute-intensive workloads in EC2. Now, as with the other Graviton-based G instances, the caveat here is that your software needs to be compatible with the ARM-based CPU architecture, which a lot of modern workloads are, especially with Linux environments. So with that in mind, the C8G instance type is really an excellent choice for new compute-intensive deployments, offering cutting-edge performance at a much lower cost. The memory-optimized instances, referenced by the letter R, are designed for applications that need a lot of memory relative to CPU. These instances have a really high memory to vCPU ratio, meaning you get many gigabytes of RAM for each vCPU core. These are optimized to deliver fast performance for workloads that process large datasets in memory. So if your application's performance is limited by how much data can fit into memory rather than by pure CPU speed, the R family is likely what you need in this case. Typical use cases for these are your in-memory caches like Redis or Mcached, large relational or NoSQL databases, real-time big data analytics where you're working with large data sets, and different in-memory computing frameworks. By providing a lot of RAM, these R instances let you keep more of your data set in memory, which can avoid slower disk I/O and speed up processing. They still have a decent amount of vCPU, but compared to an M instance of similar vCPU count, an R instance will have significantly more memory. If you find that your app or database is constantly using disk swap space, can't cache enough data, and it's reading from disk often, moving to these R family instance types can dramatically improve your performance. In addition to the R family, AWS offers the X family instances, which really push memory to extreme levels. X instances are essentially memory-optimized instances with even more memory per CPU, offering terabytes of RAM for your EC2 instance. These are purpose-built for things like in-memory databases and analytics that require enormous memory pools. For example, certain X and U instances are tailored for SAP HANA and other really big in-memory databases that might need terabytes of memory in a single server. Now, the trade-off with these types of instances are, of course, cost. They're really expensive and very specialized. But if you do actually have a use case for real-time analytics platforms or enterprise applications that need to have all the data and RAM for performance or different licensing reasons, that's what these instance types are meant for. So in summary here, you can think of the X and the related high memory U instances as the extreme end of memory optimized. When that R family isn't quite enough memory, you can look at the X or the ultra high memory U instances. In this memory optimized category, the newest offering is the R8G, which again uses the Graviton 4 processor and provides the best price to performance ratio in EC2 for these memory intensive workloads. So that's a wrap for part 1 of this lesson on EC2 instance types here, and we'll jump right into the remaining instance families and also some tips to remember all the naming conventions and purposes of all these different types, and really discuss how to pick the right type for different workloads in the real world. So go ahead and take a quick break, and we'll jump right back into learning the EC2 instance types in the next lesson. Welcome back to part 2, exploring the EC2 instance types. Let's just jump right back into it, looking at the storage optimized instance families. Now, the storage optimized family includes instances like i8G, which are geared toward I/O intensive workloads. The I family instances come with locally attached NVMe SSDs that provide extremely high random read-write performance, high IOPS at really low latency. Now, these types of instances are perfect for applications like database systems that do a lot of random reads and writes, or analytics engines that need fast scratch space, as these instances can deliver tens of thousands of low latency I/O operations per second, or IOPS, to your applications. Now, unlike the general purpose instances that rely on network storage using EBS volumes, these I instances have storage inside the physical server, which means data can be read or written to a lot faster, as there's no real network hop where you're introducing latency. Now, use cases for these could be transactional databases where, again, you need those quick reads and writes to disk, high-frequency trading systems, your Elasticsearch clusters, or really any workload where disk speed is the primary bottleneck. I-family instances often have a balanced CPU and memory allocation really similar to the general purpose category, but the distinguishing feature here is really that super fast disk. If you have applications where disk I/O is really slowing things down for your applications and workloads, moving it to an I-family instance can be a world of difference. Now, another branch of the storage-optimized instances is the D-family, where the emphasis is on dense storage capacity. D instances come with large amounts of magnetic HDD storage as opposed to SSD, and offer many terabytes of storage across multiple drives. And these are designed for workloads that need to have a lot of sequential read-write and very large data sets on local disk. These instances specialize in high throughput read-write bandwidth rather than on high IOPS. And this makes them ideal for your data applications, data warehouses, or file storage systems where you need to process huge data sets, but that ultra-fast random I/O isn't your primary need. An example use case for these could be media storage and processing, where you have big files and they're typically accessed sequentially. Essentially, the D family trades the snappy speed of SSDs for sheer volume, and you get a lot of disk space at a much lower cost per gigabyte by using the HDDs. Now, it's really important to note that the storage that comes with the I, D, and H family instances are based on instant store volumes, meaning your storage is ephemeral. And again, this means that the data on the local instance stored disks persist only while the instance is actually running. If you go ahead and stop or terminate the instance, your data is essentially lost. Now, this is different from the elastic block store or EBS volumes, which are sort of network-attached volumes, and those do persist independently of the VM lifecycle. Now, we'll be discussing EBS and EC2 storage in more depth in other lessons in the course, but it's important to understand at this point the relation of the ephemeral nature of the storage of these instance types. So if you're using these storage-optimized instances or similar instances with local disk, you should essentially plan for failure or instance shutdown, typically by replicating data or regularly backing up to durable storage options like EBS or S3. For example, if you run a database on an i3 instance, you might use its high-speed storage for the active data set, but still have replicas or frequent snapshots to avoid losing that data. This ephemeral nature is really a trade-off for getting that high performance. As a solutions architect, you need to be aware of these limitations and essentially design around it, either treating the instance store as just a pure cache or temporary data, or use replication and other backup techniques. The key point is that you don't want to store your only copy of critical data on instance store volumes. Really use it for what it's best at, fast I/O, but really combine that with a strategy for durability. Many EC2 instances also allow for different RAID configurations or other setups to improve your storage reliability, but ultimately when the instance goes away, the storage goes with it. Knowing this ahead of time, you can leverage storage-optimized instances for speed and capacity, but not for long-term persistent storage. And that's what services like EBS, S3, EFS, and others are really designed for. Next, we have the accelerated computing category of instances, which includes those with attached hardware accelerators like GPUs. AWS has P-family and G-family instances that come with NVIDIA or AMD GPUs to accelerate your workloads. These GPU instances are essential for use cases like machine learning, model training, deep learning, GPU-accelerated scientific computing, your video rendering, and even graphics-intensive applications or gaming virtualization. The P-series typically stands for parallel computing and often features the latest NVIDIA Tesla accelerator GPUs aimed at computation. And the G-series historically has been geared a bit more towards graphics, making them more suitable for things like virtual workstations, your 3D rendering, or streaming video games in the cloud. Now, when you choose a GPU instance, you want to look at how many GPUs it has, what kind of GPUs they are, and the GPU memory as well, and those determine the performance for your task. Accelerated instances use these GPU devices to perform certain operations much faster than a CPU could. So if your application can offload work to a GPU, These types of instances are what you need. They still have CPUs and memory, but their defining feature is really the attached GPU cards. AWS's accelerated instances allow things like training a complex neural network in hours instead of days, or rendering videos in real time by really leveraging the massive parallel processing power of these modern GPUs. Now, besides GPUs, AWS also introduced its own custom AI accelerators, notably their inferentia chips used in the INF instances and their Trainium chips used in the TRN instances. These are custom-built silicon chips designed by AWS to accelerate machine learning tasks. The inferentia-based instances are optimized for machine learning inference, which is basically the stage where a trained model is used to make predictions. Inference can also be done on CPUs or GPUs, but AWS Inferentia offers a way to do it at a lower cost with very high throughput, especially for models in areas like natural language processing or NLP or computer vision that can really take advantage of this architecture. So if you have a production service that needs to serve ML predictions like an image recognition API, these inferentia instances can really handle a large volume of requests very efficiently, often with better price to performance ratios than a GPU for the same task. Now, Trainium instances are more aimed at training deep learning models. The training aspect is usually extremely computationally intensive, where it can take weeks of GPU time for very large models. AWS Trainium chips are really an alternative to NVIDIA GPUs for this, and intended to offer high performance and scalability for training at a much lower cost. So these types of accelerated computing instances in this category provide excellent performance for certain types of workloads, and are really part of AWS's strategy to reduce the cost of machine learning in the cloud. AWS also provides instances with field programmable gate arrays, and these are the F1 family of EC2 instances. Now, FPGA is a hardware device that can be programmed to implement custom logic circuits. These types of instances are really for customers who want to create custom hardware accelerators for their specific algorithms. As an example, if you have a proprietary encryption algorithm, you're doing signal processing or a special genomic sequencing algorithm, or really any kind of computation that could be made parallel or faster in hardware, you can program the FPGA to do just that. Now, this requires very specialized knowledge, so these instances are used in really niche scenarios, but they can really fill an important gap. Not all workloads map really well to CPUs or GPUs. Some things could be done with a custom pipeline on a FPGA for really massive efficiency gains. Now, to help get going with your FPGA instances, AWS provides a toolkit so you can develop your own FPGA code. Your main takeaway here is just that these FPGA instances essentially allow you to reconfigure your hardware in the cloud. Now, unless you're specifically looking to optimize a very low-level algorithm and really have the engineering resources and expertise to do this, you might not ever touch these FPGA instances, but it's still good to know that they exist. And really, this is just another example of the breadth of AWS offerings to their customers, all the way from really tiny general-purpose instances to very specialized FPGA instance types. Now, to this point, we've covered a lot of different instance type categories and families, and I've gone through a lot of the letters and kind of use cases for them. So I've put together a bit of a reference table or study guide, just referencing all the different instance type families, their family type category, and a bit of a memory aid to help remember what that instance type is for and its primary use case. To help remember some of the core EC2 instance type families, just remember the Fight Dr. McPixie. If you can remember Dr. McPixie getting ready for a fight here, you'll have a tool to recall all the core instance type letters and families. I'll include this slide as a resource for the lesson here within the lesson itself or just after, so you can refer to it as a bit of a cheat sheet as well. But I like using these types of mnemonics and learning aids to help remember this information. Now let's quickly look at the EC2 instance type generations in a bit more depth here. In recent years, AWS introduced the Graviton line of processors, and these are AWS designed chips based on the ARM architecture and have really been a game changer for EC2. These Graviton processors, which are now up to the Graviton 4 in the latest generation here at the time of recording, are built to deliver outstanding performance at a lower cost and power usage than those traditional x86 chips. Now, for you as an architect, what this means is that if your software stack can run on these ARM-based architectures, you can potentially save a lot of money by using Graviton-based instances. Many AWS instance families now have the G variant, like the M8G, and these often offer the best performance per dollar. Now, it's not all just about cost with these Graviton chips either. In many cases, the performance can actually be better because AWS packs these instances with modern capabilities, like modern DDR5 memory, more cache per core, and so forth. The Graviton-powered instances tend to have lower latency and really great networking capabilities as well, partly thanks to the AWS Nitro system and really the fact that AWS controls that whole stack. Now, the latest generation instances we've been mentioning, like the M8G, C8G, R8G, all run on the AWS Graviton 4 processor, making them the first of the 8th generation in their families. And these are cutting-edge instances introduced about the end of 2024 and into 2025 here, and they represent a significant performance jump. AWS claims Graviton 4 is about 30% faster in compute than Graviton 3, and these instance families also support more cores and higher memory speeds. AWS also increased the maximum instance sizes available, where M7G topped out at 64 vCPUs. The M8G goes up to 192 vCPUs in a single instance. All these 8th gen families use modern DDR5 memory chips, which provides much higher memory bandwidth. AWS goes on to say about 75% more memory bandwidth with these Graviton 4's DDR5 memory compared to the previous generation's DDR4. These are certainly the instances you'd want to choose if you want maximum performance available in EC2 for that category of workload, especially if you're optimizing for cost efficiency too. On the security side, these Graviton 4-based instances include enhanced security measures as well. It has always-on memory encryption, dedicated vCPU caches to prevent VM inference, and really all these features come together to make instances more robust against common vulnerabilities and give defense in depth by default. So again, your takeaway here is that this new hardware and features of the latest generation of instance types typically give you more of everything, more cores, speed, memory, and even improved security and I/O. So if you're comparing older and new instances, these enhancements often tilt the scale heavily in favor of moving to the latest generation as soon as possible. With the combination of the Graviton 4 processor and the design of these 8th gen families, M8G, C8G, and R8G, have really all become the leaders in price to performance for their respective use cases. AWS's own documentation emphasizes that M8G delivers the best price to performance for general purpose workloads, C8G for compute intensive, and R8G for memory intensive workloads. So as a solutions architect, you should always evaluate whether using the latest generation instance types and these Graviton-based processor options like the M8G, C8G, and R8G could provide a number of cost and performance benefits to your workloads. Now that we know about all the different instance types and what they're best at, how do we really go about choosing the right one for a use case? Well, the first step is really to assess your workload's requirements. You want to identify what resource is most critical for your application's performance. Does your workload do a lot of computations, so it's more CPU bound? Or does it load huge data sets into memory and have large caches, so it's more memory bound? Or is it consistently reading or writing to disks or like a database, making it more I/O bound? Could it be more network heavy where it's sending and receiving a lot of data? Or perhaps it needs specialized hardware like those GPUs or FPGA types of instances. By clarifying your application's needs, you really narrow down the field of suitable instance families. This instance type selection step is really crucial, so you want to make sure you're taking your time picking the right one. If you misjudge your workload and pick the wrong type, say you pick a memory optimized instance for a CPU intensive task, you might end up with a lot of unused RAM, but not enough CPU, causing performance issues, or vice versa, that you have too much CPU and you're running out of memory, while also paying a lot for the instance that you don't really need to. So you always want to start with understanding your workload characteristics. Again, your CPU, memory storage, networking, do you need any type of hardware accelerators? Which ones of those are the most needed? Sometimes the workload is balanced in terms of needs, then one of those general purpose types of instance families is fine. But often one of these areas will really stand out as part of your workload assessment. So once you know what that driving resource is, you want to choose the appropriate instance family from what we've outlined so far. And this is often a one-to-one mapping. Again, if CPU is king, you want to go for a compute-optimized instance. If memory is more important, you'd go with one of those memory optimized R or X instances. If your app is really well-rounded and not really extreme in any one dimension, those general purpose M and T instances are likely best. For your disk I/O intensive tasks, the storage optimized category and the I and D instance family should be your pick there. And if you need GPU or other accelerators, you can look into the accelerated computing families. This mapping ensures that your instance's strengths really align to your application's needs. You also want to consider any specific requirements for compatibility. For example, if you specifically need an Intel CPU feature, you'd choose one of the I variant instances. After you've gone ahead and found that best fit instance family, again, you want to prefer the latest generation within that family for any new AWS developments. AWS keeps improving its instance types with each generation, often delivering higher performance for a lower cost. As we discussed quite a bit at this point, the latest G instances with the Graviton 4 8th generation are extremely strong in that price to performance value. If your software stack is able to run on these ARM architectures, they're often a really top recommendation. AWS often prices these newer generation instance types either very similarly or even cheaper per unit than the older ones to encourage adoption. As a result, you can usually get more performance at equal or less cost by upgrading to these newer generation instances. Now, one thing I'll mention here quickly is that when AWS releases new generation of instances, they may not be available in all the regions at the same time. So depending on when you're actually making the instance type choice, always make sure that the target region actually offers the instance type and size that you're thinking of. With EC2 instances, picking the right size is critical. AWS gives us a lot of size options to choose from, and you should certainly choose a size that comfortably handles your workload but isn't excessively over-provisioned. A good approach in your selection process is to start with an estimate of needed resources, ideally based on data from testing or monitoring, and then pick a size accordingly and adjust later as needed. AWS makes it easy to change instance sizes. You typically just stop the instance, change the size configuration, and then start it up again. AWS provides tools like AWS Compute Optimizer to recommend instance types and sizes that could be more optimal based on historical usage patterns. Also, don't forget that we're using the cloud now. Experimentation can be very fast and cheap in AWS. You can spin up 2 or 3 different instance types for a short period of time, run your specific application workloads, and benchmark them to see which one performs best. So instead of making guesses onto what the right instance type would be, what the best fit is, and provides the most performance and value, you can really try different instance types and run some quick performance tests and shut them down after. This can give you actual real data to make a decision on rather than just some gut feel best guesses. Now, another really important aspect of right sizing is the scaling component, which is really a whole other topic on its own. Your application and infrastructure architecture kind of come into play here and adds even more variables to this kind of instance size and type decision. Should you vertically scale by increasing the size of your instance or changing to a different instance family? Or do you perhaps actually reduce the size of your instance, but then add more of them to handle the load? And there's a lot to this whole dynamic, which we'll get into a lot later in the course. So to wrap everything up, we certainly covered a lot of information between part 1 and 2 of these lessons. As you've seen, AWS EC2 instance types offer really a tremendous flexibility for us as customers and solutions architects. We've seen those instance families that are optimized for compute, memory, storage, GPUs, and even more. And really how AWS latest Graviton-based processors are kind of pushing the envelope in terms of cost and performance ratios. As a solutions architect, understanding all these options is really important, as it really helps you choose the kind of right tool for the job. By aligning your workload with the proper instance family, using the newer generation for efficiency, and right-sizing your deployment can really achieve optimal performance and still control your AWS costs. Now, as you expect, AWS provides extensive documentation and tools to kind of help with all of this, and it's always evolving. So keep an eye on new instance type releases and documentation, and also include some links to the AWS documentation and some other tools in the resource section within this lesson here, or just following it for your review, and really arm you with some on-the-job aids to review what instance types exist and assist you with sizing for specific CPU and memory requirements. So with all this knowledge on EC2 instance types, you're now well equipped to make informed decisions on EC2 instance selection ensuring your architecture is performing its best and it's cost effective. So thanks for watching, and see you in the next lesson.